The heading indicator, also known as the directional gyro. As with anything else, this instrument comes in various forms with many options, such as a heading bug. It also comes in the form of a horizontal situation indicator, or HSI, or other units that are also slaved to a remote compass, but for now I am going to focus on a typical free gyro indicator. The heading indicator may be powered by different sources, such as 24 volt DC electric or 115 volt AC by using an inverter. Most training aircraft, however, use a vacuum or pressure system, the vacuum system being the most common. It is the vacuum system that we will focus on in this video. Let's look into the inner workings of this instrument. The case of this instrument seals the airflow inside. The vacuum draws air out from this orifice. The filtered air is drawn in here. This is what the interior ductwork looks like. There are several places to draw the vacuum from through this channel. A gasket on the backside of the outer shell keeps these areas isolated and sealed. The extra orifice in the back of this case accesses the vacuum side of the instrument and may be used to attach a suction gauge to the system. The air continues through the duct that is part of the framework where it is vectored into the gimbal, travels through another sealed duct, and drawn into the gyro housing here. Notice how the incoming air is vectored for the best flow through the vanes on the gyro. Once inside, the airflow passes over these vanes, then exits through the other side of the housing where it is drawn out by the vacuum. This airflow is sufficient to get the gyro spinning over 12,000 RPM, creating a very rigid and stable platform. There are many precise balancing points inside this instrument to make it as efficient and precise as possible. The gimbal is free to spin 360 degrees on the vertical axis. It is attached to a gear at the bottom that drives an opposing gear at 90 degrees from the pivot of the gimbal gear. This in turn will drive the compass card on your display. The gyro housing also pivots at its attachment points to the gimbal, giving it roughly 170 degrees to pivot in order to allow for the changes in the airplane's pitch and bank attitudes without disturbing the gyro too much. Exceeding this limit would cause your instrument to tumble, and it will take some time for it to restabilize and come back to life. The compass card may be set by pressing the adjusting knob in and turning it until you have reached your desired indicated heading. When this knob is pressed in, it disengages the card from the drive gear as it engages another gear to turn the card. Now let's add some airflow to this instrument and observe its operation. Here we can see how stable this instrument becomes. The spinning gyro stays rigid in space. When the aircraft pitches up or down, or banks, the gyro does not follow, which is what makes the compass card turn with the aircraft. Notice how rigid the gears are when outside pressure is applied to them. They are extremely resistant to movement against the spinning gyro. Also note that when pressure is applied to the gears, it causes the gyro housing to change position. This is caused by the outside force I am applying to it and causing the gyro to precess. This precession may be corrected by readjusting the compass card using the adjustment knob. These outward forces happen naturally in your aircraft by means of turbulence, turning, pitch changes, and time. When you are using a free gyroscopic instrument such as this, you must remember to check its heading and make any adjustments needed about every 15 minutes. In order to do this, you will need to use the magnetic compass for a reference. But remember, that magnetic compass is only accurate in straight and level, unaccelerated flight. If your heading indicator shows excessive precession, it is either going to be caused by a weak vacuum, a filter that is getting clogged, or this instrument is simply wearing out. A properly working heading indicator will take several minutes to spin down, but watch in real time how quickly this one does and how it catches and spins the compass card at the end. The heading indicator is another one of those instruments that is not required for VFR flight, but it is required for IFR flight. Its only operational checks for the pilot is that it is following known headings while on the ground, and your suction gauge shows sufficient suction for the vacuum-driven gyro instruments. This is usually right around 5 inches of mercury, give or take. See your POH for the specific value for your airplane. It should also be shown in a checklist item for your run-up, as well as a green arc on the instrument itself. Hello again, my name is Ryan Anderson. I am an ATP and a CFI for airplane, instrument, and multi-engine aircraft. Thanks for watching this video. I am continuously working on creating more of these videos to continue your education in the aviation field. Whether you are a beginner or a 30-year veteran pilot, there is always more to learn or to relearn. It is my goal to make safer pilots through the knowledge of the industry and your aircraft. Please subscribe to my YouTube channel, Ryan Anderson 3620, and you will be notified when new videos are introduced. Also, feel free to comment on my work and bring any suggestions you would have on areas that you would like to learn more about. If you have any questions, please feel free to ask me here, and I will do my best to get back to you. I also have a website where I link not only my videos, but many others that I feel are worthwhile watching. That site is www.learntoflyfar.com. There you will also find a link to my email and more. Keep learning, fly safe, but most of all, have fun.